All right, lesson number 22 is all about buffers. And we start off by asking which of the following are a buffer solution. So in order to answer this, we need to know what a buffer is. So a buffer resists changes in pH. But what makes a buffer? A buffer is when I have a weak acid and its base pair. Right? So, for instance, HA and A minus, right? Where HA is the acid, A minus is the base. Okay. A lot of times the conjugates, right? You add as soluble salts. You can't have F minus by itself. So what you do is you add NaF to a solution, and that dissolves to form Na plus and F minus. Okay. So it's a weak acid and base, but it has to be a pair. All right, so let's go through these and figure out whether they are a weak acid or whether they're a buffer, whether they're a weak acid base pair. All right, so for the first one, we have HCl and Cl minus. So HCl and Cl minus are an acid and a base pair. But here's the thing. HCl is a strong acid. Okay? So this is not a buffer, okay? Because what's going to happen is this is one way. We don't have any of that backward direction, right? So it's not going to be a good buffer. How about the second one? We have H2S, and we have a Ka for that, and we have F minus. So, and that has a Kb. So those are a weak acid and a weak base. But are these two things related? No. There's no way I can get H2S, it loses some H pluses and get to F minus. So this, even though they're a weak acid and a weak base, they're not a pair. All right, C. ClO minus and HClO. Okay? Well, HClO, if this is an acid, it's going to produce ClO minus. So this is an acid-base pair. And let's see, this has a Kb of 3.4 times 10 to the minus 7. So this is a weak base. And we could figure out the Ka, this would be a weak acid. So it's a weak acid, weak base pair. So it is a buffer. All right, D. We have H2S and NaHS. Is this a weak acid, weak base pair? Well, remember what we said. We said that a lot of times we add in things with a sodium salt because everything with sodium is ionic. So this is going to form HS minus. So are H2S and HS minus related? We'll look at the difference between them. There's a hydrogen difference, and if this were to lose an H plus, I'd get HS minus, right? And this is a weak acid, as you can tell by its Ka. So this is a weak base. So this is also a buffer, right? So we need a weak acid and a weak base, and they have to be a pair. All right, so now let's go ahead. And now we're going to go ahead and we're going to look more at the calculations involving buffers. So let's say for video problem 22b, we're asked what is the pH of a solution containing HF and F minus. We're given a Kb and we're given the moles of both. All right, so first, is this a buffer? Well, HF and F minus, these two are related because if I lose H plus from HF, I'll get F minus. And notice that Kb for F minus, that means this is a weak base, and this is going to be a weak acid. So this is a buffer. Okay, so what we could do, because it's buffer, is we can use the Henderson-Hasselbalch equation. All right, in this case, it'll be F minus, that's the base, over HF. Okay, so I need to figure out Ka. I'm given Kb. Don't just say, I'm just going to use it. No, I need to convert between them. Remember, we learned that Ka and Kb are related by this term Kw, right? Kw equals Ka times Kb, right? This is our for an acid-base pair. All right, so rearrange this. Ka equals Kw over Kb. That will be 1 times 10 to the minus 14 over the Kb that we have up there, 1.5 times 10 to the minus 11. That's going to go ahead and that's going to get me 6.67 times 10 to the minus 4. That's now my Ka. So now I can go ahead and I can use that in order to find my pKa. Because pKa is negative log of my Ka plus the log of F minus, I'm told I have 0.055 over 0.025. All right. When we talk about Henderson-Hasselbalch equation, we can either use moles or molarity. Here we're given moles, so we just use that. All right. So now this, if I take the log of this and then make that negative, I get 3.18, which kind of makes sense. This is around 4, so this will be, the answer to this will be somewhere around 4, right? 3 to 5. And then this will be plus log of 0.055 over 0.025. That's log of 2.2. It's going to get me 3.18 plus 0.34 or 3.52. That is my pH. Okay. Notice how I have more base than I have acid. So that means my pH is going to be higher than my pKa. Let's look at this on the screen. The first thing you always have to do is make sure it's a buffer, because this equation does not work if it's not a buffer, right? If it's not an acid plus a base, weak acid plus weak base. It only works for buffers. And then I go ahead and plug in. Make sure you know that it's the Ka I used, not a Kb. All right, so let's move on and let's use the Henderson-Hasselbalch equation one more time, but let's use it for something else. Okay, in this problem, we're saying we're working in the lab and we want to make a buffer. We'll get into this next lesson, but a lot of times we want to have buffers because we don't want the pH to change. We want the pH of a reaction to be in a very narrow range, right? They also use buffers a lot in things like shampoo, etc., right? Because we don't want swings in pH. All right, so this 4.15 equals negative log. We have our Ka, that's 4.5 times 10 to the negative 4. Okay, and what's it asking for? It's asking for the mole-to-mole ratio of base to acid. That's this value. Okay, so we have most of it, or we have pH and pKa. Now we want to find this. Okay, all right, so this is 4.15. So we're given this, we want to find this. Okay, so we're going to have to rearrange this sum. Let's go ahead and plug stuff in. So 4.15 equals 3.35 plus log of F minus over HF. Okay. This gets me 0.80 equals log F minus over HF. All right, we want to know this. We don't want to know the log of it. So what we have to do is we need to take 10 to the both sides. So that means that F minus over HF is going to give me 10 to the 0.8, which is equal to 6.31. That's the ratio of my base to acid I would want to make this buffer. We'll talk more about making buffers in the next lesson. All right, here it is on the screen. This is a little bit different, but it's still using Henderson-Hasselbalch, and it can do that because this is a buffer, right? We can only use it. We're given pH, we can find pKa, and we rearrange to find this term. All right, bye-bye.